Hopefully you can hear me. My name is Keith Locko. I am the Global VP of Marketing and Business Development for Maxcess. We are here today with Aaron Powers, who is our Global Brand and Product Manager for Tidland, a Maxcess brand. TJ Utchik, who is the President and CEO of Valley Grinding and Manufacturing, and Tim Kiley, who's Director of Sales for Valley Grinding and Manufacturing. This is our first partnership webinar today. We're going to be talking about optimizing shear slitting operations, and where this comes from really is a strategic partnership that was formed by Valley Grinding and Maxcess, particularly the Tidland brand, to really help better serve, enhance customer service and support, education opportunities, product development with Valley Grinding and Maxcess, as well as looking at how we optimize performance of slitters and slitting systems. So welcome, everybody. We appreciate the interest in our first webinar, and we hope to do these about once a quarter going forward if you find value in them. As I said, we are planning on doing probably about 40 minutes of presentations and slides. If you have a question, please write that question in the chat, and we will get to it at the end of the presentation, and our subject matter experts will answer that. So without further ado, I'm going to go over the agenda real quick, and then we'll turn it over to our subject matter experts. Today, what we're planning on talking about is material properties, the various slitting methods, but then we're going to focus on shear slitting in this particular overview. And as we get through the elements of shear slitting, then we'll talk about blade profiles, maintenance, service and support, the benefits of slitting systems, and then open it up to questions and answers. So without any further delay, I'm going to turn it over to Aaron Powers from Maxcess, who will take you through some material properties and other information. Thanks, Aaron.
So, one second, Keith. We did have somebody say they can't hear us. Can we get a few more participants to let us know if you're experiencing the same issue?
Yep.
No issues. Okay, thank you so much.
Okay.
Okay, well, we'll get started then. So thanks, Keith, for the introduction. As Keith said, my name is Aaron Powers. I'm the Global Product Manager and Brand Manager for Tidland, based in Camas, Washington, where Tidland's sales, engineering, customer service is located. And the first topic here we're going to cover is materials and material properties. And before we go into too depth, when we talk about slitting, we're breaking materials apart. And most of the time, in a engineering college, if you talk about this classes they offer and how things break, called fracture mechanics, this is all focused on how to prevent things from fracturing, how to prevent cracks from occurring. And you're studying how they come apart, why cracks propagates, all the forces at play, and that's really what is most common. Most of the research is on. But what we're trying to do with slitting, go to the next slide, is we're trying to focus those forces, those same forces, only and create cracks as opposed to prevent them. And we're trying to control them in such a way as those edges of both sides become are clean and have a usable edge for the process that follows, or the product being made. So to do that, you really have to understand the material itself and what those properties are. And there's really 7 properties overall that impact, what the best way will be to slit that material, and they're listed here. So caliper, the thickness of the web, density, how densely packed the fibers are, how much material is within that thickness, right? Elongation, how is the material stretchy? Stiffness, when I bend it, what happens to it? Is it going to snap, or does it flex? Compressibility, what happens if I compress? Does the material recover, or does it stay compressed? Abrasiveness and tensile strength. So all of these factors play together, and finding the right slitting setup is really a balance of all of those factors. There's usually one dominant factor that's going to dictate the direction and that you need to go in terms of which type of slitting, which we'll talk about here in a minute. So for those types of slitting, there's three main types we want to cover. And I'll also mention, why each one might be used versus the other. So first off, razor. Razor is the most basic type of slitting. You have a razor blade, and the web is being drug across or pulled through or across the blade. Very inexpensive, mechanically simple, and can work with very narrow slit widths. And so these are the main advantages of razor. Disadvantage, really the biggest one, is safety. Anytime you have exposed razor blades, that's the most dangerous type of slitting operation from in terms of the operator interacting with those blades. And then for some materials, it just won't work well. Razor blades are thin, and for some materials won't give a very good cut. So next up, crush. Crush, here, it is the main advantage with crush is it's very simple to set up. You have a solid anvil and you have a top slitter, and there's really fewer factors to control. Crush is more of a pizza cutter against a board type of approach. Here in the picture, you're in the bottom, the blade is pushing down with a down force, and the material is being forced down into the sides away from that blade profile to create that crush. The crush slitting works very well on certain tough products, tough materials that can't be slit with other methods. Downsides are edge quality. Because of that, you're really pressing the material and pushing it apart. The edges tend not to be as clean and as other methods like shear. And generally, you can only run at lower speeds, and that's due to combined run out of those top and bottom anvils and the forces thereon. It generally won't be able to run as fast as say a shear method. And so that brings us to shear. Shear, which is continuous scissors, has advantages in edge quality, gives good clean edges. If you can cut a material with scissors, you can cut it with shear slitting. Works for all types of material. You have a wide range of options in terms of setup. Those options allow you to really tailor that slitting process to get the best results for the particular material. Higher speeds and greater efficiency. The disadvantages from a material standpoint are it's more expensive because you have both top blades and bottom, and so you have more components that go into the system. And also setups can be more complex because you have more parts and there's more factors that you need to control and get right to optimize your process. So what we're going to focus on for the rest of the webinar is shear slitting, and that's because it is really the best general purpose, can apply to many types of material, gives the best edge results, and is probably, I think most people on this webinar are going to have some type of shear process in their facilities. So what we're doing with shear, we're like I said, continuous scissors. The material is being displaced vertically by opposing blades, and those blades have to overlap, and there has to be a nip point to create that cut. And typically, with shear slitting, you're going to have individually mounted slitters, like you see here in the photo, individually mounted with control for the different parameters built into those knife holders on the top, and then bottom blades on a knife shaft, as you see. Those bottom blades are typically driven with a motor, and the top blades are not. So they're traction driven with the bottom, which means for the top blade to spin, there must be contact, and the friction between those, the rotating bottom blades, is what turns the top. And then generally we have both pneumatic and electronic options for controlling those. So the photos here on the right side show you an example of some of the different results, or what might be a poor result for a slitting process, and different problems. So those could be dust, it could be poor edges, and we say that it's cracks, distortions, bending, any type of deformation that might cause that edge especially if it's part of a product that's being used, that might render it a scrap, for that process or product. Dimension variation. Also, you can see blade wear, damage, and trim removal. These are all symptoms of a poor performance with a slitting operation. And so how you address those, we move to the next slide, is really in having the best setup for that material. And to talk a little bit more about that, I'm going to turn it over to Tim with Valley Grinding.
Good morning or afternoon, as it may be. So I just want to talk about shear slitting. Aaron touched on the other types of slitting, crush, razor, but again, the focus here is shear slitting. So there are two main types of shear slitting. The first is wrap shear slitting. Eva, can you go back to the crush slide quick? Just to give people an understanding what the wrap looks like. Aaron's slide. So wrap simply means, so that red line is represents the web, so it's wrapping around the female. So just so you understand what that is, and that's commonly used in crush applications. You can go back, Eva, thank you. And so that's typically used for very narrow slits, delicate materials that require a lot of web support, but it's more of a niche thing. In that case, that red section represents the wrap, and you can cut anywhere along that red point. So you can move your knife holder or your blade anywhere along that stretch. However, tangent slitting is a much different animal, and there are a lot of factors involved. And so we're going to talk about tangential shear slitting, which is illustrated on the bottom right of this slide. And you can see it's simply a matter of a bottom band slightly moving up into the web to create tension, because certainly you need tension. So we're going to focus on this method. And so when we think of shear slitting, most of us think of the common everyday scissors, like Aaron mentioned, and that's what we're doing. But the scissors we're running is continuous. So if a household scissors has a screw loose, it won't cut, right? So likewise, if the conditions are not correct, when you're setting up your shear slitting application, you will not be successful. So our focus for the next few minutes will be on the three main principles of shear slitting, and they are overlap, cant angle, and side force. So overlap. Now we're finally to your first slide here. So overlap, which is also known as depth setting, most people know it as depth setting, simply means that the top knife extends below the web and beyond the OD of the bottom band. And you can see this in the first illustration on the upper left there, excuse me. And the top blade has to be below the surface of the web, or obviously it's not going to cut it. Also, you need overlap to have side force. Of course, there's nothing to move it against if it's not lower than the OD of the bottom band. So where this touches is called the nip point. And the nip point is simply the leading edge of the blade where the web enters the slitter. And if you don't have the proper setting for this nip point, you're technically not shear slitting, and all of those illustrations that you saw in Aaron's slide, the failed cuts or slits, you're opening yourself up to experiencing that. So to gain an understanding of how this works, we need to understand how, as I mentioned, the bottom band penetrates the web to create tension. So the little green section in that illustration represents the point within the cut, or within the web rather, where you're actually allowed to cut to be shear slitting. So it's a very small window, and we call it the cut point or the nip. And if you're not in that section, you'll experience varying levels of failure. And it's really one of the most important concepts to understand, because I mean, none of this other stuff matters because you're not shear slitting if you don't have your cut point or your nip in the proper place. So so we're talking about blade wear and life, nip speed, nip geometry, and slit edge quality. And next slide, please. And so the overlap, again, there's many factors to how this works, but one of the things that overlap can influence is your wear resistance. So the blade-to-blade abrasion accelerates because more surface area is touching. More area on the blade is wearing as it rotates, causing the premature wear. The nip, if you set it too deep, moves upstream and descends below the web, meaning you are in front of the supported part of the web, and in theory, not technically shear slitting. So creating this unsupported slit condition, again, you're opening yourself up to many potential issues with your cut quality. And then when your overlap increases, you also can slow the upper blade speed, and that's simply because you're introducing more friction on the blade. So improper overlap contributes to poor slit edges on both sides and edge distortion on the unsupported side. Now imagine, okay, Eva, can you go back to slide 13, please? So imagine, look at the upper blade overlap of bottom illustration. Imagine your web traveling through those two blades in the upper left illustration. On the inside of the cut, there's no obstruction. The web just guides over the female and continues on. However, on the angled side of the cut, the material needs to deflect around the upper blade as it passes through. Most top slitters are ground with a double bevel to help minimize this effect. But when that top blade is set too deep, the impact of the web deflection is magnified. Thank you, Eva. So overlap is absolutely crucial, and one of the things that we train on is minimum overlap to achieve the cut. You'll see later that there are different factors to the depth of your overlap. Typically, for most of you, for 90% of you probably, it's the standard is anywhere from 30 to 40 thousandths overlap. But yeah, certainly minimum overlap to achieve the cut is crucial. Eva? So cant angle. Many of you may not know what a cant angle is. You may be hearing this term for the first time. So the photo on the bottom right will help you understand how this simply allows us to close the nip and allow for a specific cut point. Okay, it's simply the angular relationship between the bottom band and the upper blade. So closing the nip. So shear slitting requires a cant angle to achieve a single cut point. And just like a scissors, the angled portion of the geometry allows for the shear section. I assume everyone listening has wrapped a present at some point. I hope so anyway. If I were to ask for a show of hands, how many of you started by actuating the scissors and then at some point just plowed it through the paper? I think all of you might raise your hand. In this case, all you're doing is plowing the scissors through the paper and on a smaller scale, creating micro tears and dust. Similarly, without a cant angle, all you are doing is plowing your web through the slitter. Now, certainly, I don't care what my presents look like when I get them, but your customer certainly cares about the quality of the cut they're receiving from you. So blade wear in life, the greater the cant angle, meaning the more angled that it is, the greater the blade wear. The force is more focused on the tip of the blade, and it creates more friction. If there is no cant angle, so the opposite effect, the blades aren't working together, and you're not even shear slitting. And so certainly, in that case, you can also prematurely dull your blade because it's not working in concert with the female blade. Side force can change or even collapse your cant angle if it is excessive. I've seen certain folks who have it so tight that you can't even move it. And so naturally, I mean, it goes without saying that you're gonna wear your blades much quicker if you have increased side load. Slit edge quality, there are two extremes that can result in poor cut quality. Too much cant angle causes greater web deflection. So again, on the angled side of the blade, the web needs to deflect around that blade. And if you have more angle, certainly the geometry of that will cause more travel of the web around the blade. No cant angle, of course, means you're not even shear slitting. And there are times when folks, maybe they have the cant backwards, or for whatever reason, they don't understand what's happening, and they have what we call an open nip, meaning that leading edge that's supposed to be closed is actually open. Next slide, please. So how to measure this? This is, I don't even think we have time to go through all this. This is very complicated math, really. It has a lot to do with the OD of your top blade that you're using and the OD of your bottom blade, the material you're running. There's a lot of factors involved, okay? There are some knife holders out there that require you to figure out what is the necessary cord length, what is the necessary cord length for your application. And it's actually, like I said, quite a math problem, and it's not something you want to change when optimized, because operators out there typically, it's difficult for them to understand this, and the last thing you want to do is have your operators changing your cant angle back and forth. So what Tidland does, they have a cant key brass plug on their knife holders, and it takes all the guesswork and anxiety out of the equation. And I just so maybe many of you probably know what this looks like, but this is simply a brass plug, and you make sure that the arrow matches the arrow on the blade cartridge, and it's that simple. So just something to consider. Next slide, please. So different materials require different cant angles. This chart provides great recommendations and is applicable for nearly every situation out there. Tidland produces everything from your 0 degree cant key to 1 degree, so 0 degree being for crush cutting. Their knife holder system takes away all the guesswork. The 1/2 degree cant keys are used in about 80+% of all applications, but don't hesitate to connect with Tidland to ensure that you're optimizing this critical factor. It's understanding what you should be running is half the battle. So there's absolutely different requirements for different applications, but the principle to remember for every application is this: just like minimum depth setting to achieve the cut, it's minimum cant angle to reliably slit your web. Next slide. So blade side force. So many of you may know this term as side load, same thing. So obviously this is required for shear slitting. The knife holder I showed you, the knife holders that were in Aaron's slides, they have what's called a traction blade. So the blade here spins freely. It's not driven by anything, but the bottom knife is almost always driven or connected to a shaft or a motor. So the top knife being mounted to a holder with a bearing is the traction blade, meaning you must have contact with the male and the female blade. So it only rotates relative to the friction or side force of the driven bottom. Side force, closing the nip on heavy materials. Heavier materials can cause the top knife to be forced away from the bottom, so you may need additional side load. So again, the principle here will be minimum side load to achieve the cut. Aaron gave me a great illustration for this when we were discussing this, and he said, imagine using a children's scissors to cut cardboard. It's practically impossible. And if you are able, you'll just tear it. You won't really cut it. So side load is dependent on your application. But in all cases, it's minimum side load to achieve the cut. Blade wear and life. Of course, we already touched on this, but side load, if you have excessive side load, naturally, the more friction you have on your cut, the faster your blades are going to wear. So it just stands to reason. Blade wear is relative to that force. So when setting the top blade, though, you must have enough load so you do have the traction. The blade must rotate with the female, but not so much that you don't have what we call slippage. Slippage is simply the top blade able to move independently of the bottom blade, okay? If it's difficult to rotate the male blade independently of the female, you likely have too much side load. And that's something, it's a very simple audit to go out to a machine and just grab the hub and make sure that it's not too tight. The other issue with side load, however, is now cant angle, like for a Tidland knife holder, that's not something your operators need to worry about. It's built into the knife holder, right? But you can actually take away 2 of the 3 principles of shear slitting by too much side force. So what happens is that side, or that cant angle, has so much load that it collapses the angle, and then you don't have cant angle either. So 2 of your 3 factors are gone. So One more point about excessive side load is this. Especially if you have many cut positions, if your operators have excessive side load, many times, depending on the drive, you can actually affect the overspeed of, and I think Aaron's going to talk about overspeed in a little bit, but you can affect the overspeed of the female. So that shaft that's being driven at a certain speed to cause your top knife to drive at a certain speed, those things go away when you have too much side load. It can certainly be impacted. So next slide, please. So blade side force there's different ways to apply that, and there's many different knife holders out there. Many of them leave much to be desired. They don't account for the precision and rigidity necessary for you to be successful when shear slitting. Holders that basically have a bearing at the end of a bar make it nearly impossible to replicate the side load, not to mention consistent cant angle. Flexible springs cause inconsistent cant angles when applying side force, and the precision blade alignment, it's a little better option. Pneumatic cylinder systems give you flexibility to help you properly position the top and bottom. However, it is certainly the best option, and air pressure gives you the consistent side load. Side force is not relying on a mechanical spring or operator judgment, and it also eliminates any concern about cant angle accuracy. Next slide, please. Fundamental side force designs. So floating blades and swinging hub designs are not reliable options for maintaining proper side force. The floating hub design is really the only thing that allows the blade to maintain proper traction, even if the blades or other machine factors, because there's many things that, I mean, not anything in this world completely runs true. So, you have your shaft that might run out, the bearings in your shaft. You might have some blade run out, but the floating hub design allows you to maintain the proper traction that might be causing axial run out. Next slide, please. So side load method impacts blade profile. So dished or back beveled top slitters require that any knife holder which tilts the top blade when side loaded. So if you have a flat blade in that case, and it's tilted during side loading, it could cause the contact point to move from the actual point of the blade or the proper cut point. And this creates an open nip. The cutting edge is open, so the flat side of the blade is contacting the bottom instead of the actual cutting edge. A flat upper blade, which has been tilted during side loading, will cause the contact point to move away from the proper cut point, creating an open nip. Next slide, please. And just to summarize side load, side force certainly is necessary for traction. Heavier materials can stall blades and require more side force. Side force can affect cant angle. Certainly you can completely collapse it. And excessive side force increases wear and chipping. And so in short, the three principles we've just covered have many variables, but please remember that the best success always requires minimum overlap or depth setting, minimum cant angle, and minimum side load or side force to achieve a successful cut. And with that, we'll go back to Aaron.
Okay. Go to the next slide. All right. And so now I'm going to cover a few things on the mounting geometry and some of the impacts of this, which are very related. You'll see to the topics that Tim just covered. So for tangent shear slitting, the photo or image we have here in the center, there's two concepts that you have with those overlapping blades. You're going to have on the bottom blade what's called out here in orange is the arc of overlap, and then on the top blade the arc of rub. And so the arc of rub on the top blade, that's the area or the surface that the web is rubbing against the top blade, and then on the bottom blade, that's where the two top and bottom are rubbing together. And so with true tangent shear slitting, you have to have a setback of that top blade versus the bottom in order to achieve your ideal cut point at top dead center of the bottom blade. And this is the typical setup for most applications. As we mentioned, for some, if you have no setback with some wrap, then for pressure sensitive web, foils or brittle materials, this might be appropriate. But for most materials, the true tangents setup is going to be the optimal. Here's the wrap tangent showing where without a setback, if without a setback, you would have to do a wrap in order that the web enters the slitter at the nip point. If you don't have a wrap, excuse me, if you don't have a wrap without a setback, now as that in that overlap graphic that Tim showed, that's where your nip point falls outside of the web line and you're no longer shear slitting. So this is really only used on very narrow slits or unstable web products. The amount, and just one more comment on that, the amount of setback is really something that's designed into the system with the orientation of your guide bar and where your bottom slitters are. It's really not something that once it's designed ever should change, and therefore isn't something that typically is adjusted on the knife holder or on the knife holder itself. So you typically built into the machine. And so the next topic then is speed and overspeed in particular. And so because the top blades are traction driven by driving the bottom, and you have this overlapping area with the side pores pressing them together, what you need for a good slit is for at the nip point, both blades, top and bottom, have to be moving at least as fast as the web. And typically you run the bottom, you have to run the bottom blade up faster, which is called overspeed. And the reason for that is simple. I'll go back to the scissors example with wrapping presents that Tim brought up. So when you're plowing the scissors through the paper, if you leave, and I have a pair of scissors here, if I'm doing this and I leave my scissors open, I don't close them as I'm cutting, I just leave them open and I just push them through the paper. Especially if it's a very thin wrapping paper, it starts to bunch up as it enters the scissors, right? Well, the way you can stop that from happening is as you're plowing through, if you slowly close the scissors, then it actually will cut as you're doing that, as you're moving it through. And when you do that, I'll do it one more time. If you can see my camera, as I'm closing these scissors, the nip point actually started here. And as I close them, it moves along the surface of the scissors and right now is here. So by closing the scissors, you're overspeeding the nip relative to how fast the scissors are moving through the paper. So that's overspeed. Overspeed is necessary to prevent that bubble from forming. We go to the next slide. So those factors, the amount of friction and the radial speeds of each blade, there's some pretty complicated math that goes into determining based on the diameters of your blades and also how much overlap, what overspeed is required so that your nip speed is equal or faster than the web speed. The main takeaway is as you increase overlap, because when you increase the overlap, what you're doing is you're decreasing the effective diameter or radius of rotation of that top blade because the area there more of that top blade is covered and coming into frictional contact with the bottom. As you increase overlap, the driven bottom must be driven faster in order to keep the nip speed at the web speed. And so changing your overlap changes the amount of overspeed that's required to avoid that web bubble ahead of the slitter. And so typical overlap might be between, depending on, in a typical application, might be around 5%. But as you'll see here, or I'm sorry, overspeed, as you'll see in a couple of the examples, depending on material, sometimes you might need much more. So here's a photo example of a polystyrene application. Here, the problem you see on the top photo was these angel hairs. And what was happening, there was running at a relatively higher overspeed. That friction was creating heat on the blades along with the material, and that heat was actually causing the material to warm and extrude through the nip rather than be slit. And so the solution here was minimizing the overspeed to prevent that excessive heat from the additional friction, and also ensure blades are sharp, not showing signs of wear, potentially looking at carbide, and that would be, the path to minimize this type of angel hair defect that you see in this example. So in this case, minimizing overspeed is effective, right? If we go to the next one, this is a nonwovens example where you have tightly packed nonwoven fibers. For this example on the top, you see what looks like a slit with low overspeed, where many of those fibers were not slit through and are still connected. And that means as the web is separated, they'll be breaking apart, which creates dust and other issues. The bottom photo shows that same material with 100% overspeed. So in this example, increasing overspeed also ensured complete cutting of the fibers, and it overcame this web material, which is very bulky and creates a lot of drag on those spinning blades. Driving faster was the way to overcome that and make sure all of the fibers were slit. So the amount of overspeed really is dependent on the specific setup and the geometry that you have, as well as the material. Okay, turn it over to TJ.
Hello, everyone. Thank you for your time. Once you're slitting properly and practicing what the gentlemen have already shared with you today, there's still some best practices that can help you be optimal. It sounds elementary or common to us that you need to sharpen your knives, but you'd be surprised there's a lot of people, especially with female knives and anvils, that leave them on the machine too long. It's always, material and machine speed dependent, but you should be regularly changing not only the top knives, but that female knife as well. Sometimes it's a month, could be 2 months, but certainly it's not going to be much longer than that. Some things we can help you with is managing your inventories. When your knives ultimately get ground too much, they change in size, they get too small, you need to replace those knives. That can be a problem at some customers who orders them, who brings them out to the machine. Our system, we take and we remove those knives from service when they get too small, give you a new knife, 1-for-1 exchange. You don't have these big material buys or someone going out buying 100, 200 knives at a time. And essentially, you never run out of knives or you never run short. Second key point is we all love data in this world. If you're utilizing Valley Grinding and Maxcess, we have a lot of data. If you're already a customer of ours, we have 10 years of data, how many new knives you're running and how many regrinds you're doing. And we know that for every asset you have in your facility. So please just ask us. We can give you that information. A lot of times that's very helpful for return on investment studies. You want to try to get an upgraded knife material and see what the return on investment is. We can provide you with all that data. You don't need to keep track of it. We have it. Just please ask. Another thing that's unique is many of you have multiple lines and multiple assets in your facility, not just one machine. If you're running different materials or different grades, it's not always the best practice to run the same knife setup on each machine. It may be unique to your speed or, again, your material or some of the things the gentleman talked about. We can help with especially marking those parts, giving them special part numbers, QR codes, all different ways to keep those separate for you. So again, it takes it out of the operator's hands as far as where do these blades go and what machines do they run on. That's something, you know, all you need to do again is ask for. Also, ultimately, with Maxcess and Valley Grinding, remember you have outside service reps that want to come to your facility and share what we know. You can send any of your knives to us. We're here in the United States. We're doing this work every day. We can grind a knife, put a special angle on for you, get it back to you and give you a trial within a day or two. So please utilize that. Next slide, please. We threw a lot of information at you today. There is a Principles of Shear Slitting Training manual on our website. You just have to go to valleygrinding.com and /slitting manual, and you will get all this information and more. And you can sign up there to have Aaron and the Maxcess team and us come to your facility and train. We train, we'll do multiple shifts. So please utilize that. Also, I want to stress that maintaining the OEM finish and blade geometry throughout the life of the knife is very important. Once you go through this practice and you have your optimal setup, you want to keep it. So when you send your knives out to someone, or if you're regrinding them in-house, you need to make sure that your primary angles, secondary angles, back angles, and finishes all come back to you consistent and the same as the day you bought them new, or what we designed with you for the spec on your machine. How we do this, again, we have unique part numbers for every customer, every asset of yours. We have notes, so we can put special unique angles on all of your knives and keep all of that separate for you. Okay, the last slide here. Again, we will come and do on-site training with you guys. Utilize us, please, for reverse engineering. If you have knives in your facility and you don't know what material grade you're running or what angles you have, or if there's any issues with that, Maxcess and Valley Grinding, we have full testing capabilities here in the United States. We can tell you exactly what material you have, how sharp your knives are, and help design with you what the best next step for you can be. And then don't forget that when your process changes, or you change materials, or now you're selling a different grade, please reach out to us so we can give you some tips and potentially help you with a better angle to meet your needs.
Okay, Nick, I wanted to add a couple things here just on systems. We've talked a lot about, you know, kind of the technical side of knife holder setup and what goes into it. You know, knife holders are just one part of a slitting system, and they can't work by themselves. And in particular, you know, Tidland has a nice range of automated slitting systems, you know, that can address not only some of the individual knife holder challenges, but also from a system setup perspective as well. So, you know, quickly, you know, why automation? We have safety issue number one, always. So anytime operators are manipulating knives, adjusting overlap setup on a machine, moving side to side with sharp blades, that's an opportunity for an injury. Eliminating that with automation is a great way to address it. The return on investment. So the more knives you have, the more setups, the more often you have to make changes, the faster the return on investment from setup time reduction. And then accuracy, repeatability. This is where, with newer operators, skilled operators retiring, newer operators taking their place, that from a training standpoint, the more automation you can do to address those ensures the right setup every time within spec, and repeatable, so that both the equipment doesn't get excess wear, the people are safe, and the product that's being produced is within the specifications of your customers. And in Tidland in particular, where we focus our systems and knife holders on our flexibility, trying to make it easy for operators to use. They don't have to do math when adjusting trim positions, for example. Simple to train, and robust, where it's not gonna, if somebody moves a knife by hand, our systems won't get confused and throw up an error and cause downtime, for example. So those are some of the concepts that that we offer within our automated slitting systems. Okay.
Thank you. Thanks, Aaron. A special thank you to Aaron and TJ and Tim for getting that information out to you guys. A lot of information. We know as questions came up, we did record this, so that will be available. We did have some questions come in before we get to our frequently asked questions. So let me share those with our subject matter experts here, and you guys can kind of field what you're talking about. Daniel M., as we were talking about the overlap slide, was inquiring, does desired blade overlap vary with the class of slitter or blade diameter?
Yeah, so it's a good question. The amount of overlap is in general, we recommend, consistent amounts. It's really going to vary more with the material you're slitting. It gets back to the properties. Some materials require more, some materials require less, and that goes hand in hand with the blade profile that you're using as well. Any time you have a question on what's the best setup to slit a particular material, really the best way is if you can get us samples. We have all the knives, all the knife holders, different profiles. We're more than happy to do some slit testing, plunge cut, and other types with different setups, and let then this is the optimal one in terms of side force, overlap, blade profile, and pressure.
Got it. Thanks. Next question comes from Justin. Can someone explain how to adjust cant angle on the pre-performance Aaron knife holders?
Tim, you want to take that one?
Sure. Well, I can't even tell you how many different knife holders are out there, and many of them do not. I mean, most of them do not have a cant angle built in, which I can't wrap my mind around why that is. But knife holders certainly have to have a cant angle. If they are adjustable, you can use that chart that we had up earlier that talks about the different materials. And again, how to adjust the cant angle is dependent on the knife holder, right? But what you're trying to achieve is another thing entirely. You're trying to achieve the proper chord. You use a feeler gauge, and a lot of times, if you don't know what's going on, if you don't know if you have cant angle at all, the most important thing is that you have cant angle. It's better to have too much cant angle than no cant angle at all. So if you have a feeler gauge in your maintenance shop or something, and it's very simple. The photo, I think it was this first or second slide that showed a feeler gauge behind or in between the slitters, behind the cut point or the nip. just making sure that you have that cant angle is your top priority.
Thanks, Tim. Adam asked, is there any guidance for how much space can be in between a slitting anvil and a web support anvil spacer?
So, that might depend also on the material. It's not so much about where the support is. I mean, you want to maintain tension, but the main thing we recommend is that web penetration that Tim talked about. So make sure that, you've got, typically it might be 15 to 60 thousandths for the anvil ring penetrating up into the web line. And then you need your in-feed exit idlers positioned at such a point which, depending on the material, the tension you're running, you get that table right for slitting.
Got it. Next question is from unknown participant. Any pros/cons to using O-rings instead of springs on blade holders?
So I think I can answer that one too. So that one gets to, there's the graphic, I think one of the slides Tim had that showed some of the different blade holder setups for applying that side force, and really all of the mechanical, like the spring type methods where you're tilting a blade, these are they're variable based on how the setup can create a lot of variability in how much side force, what your cant angle is, and some of these different factors. That's why Tidland knife holders are pneumatic, which gives a much more consistent side force, maintains the slitter geometry for nip point overlap and so forth. So I would say the pneumatic is really the baseline. All the other types, there's really various drawbacks to those. Really the best in class would be electronic, which we have. But in terms of, especially if it's a new, if you're looking to add or upgrade a slitting process, I would definitely look at pneumatic knife holders.
Thanks, Aaron. Jason wrote. Oh, go ahead. Okay. Jason wrote, how much should the anvil roll be overdriven versus the web speed?
So typically, standard is 3 to 5%. That's kind of the industry standard. As Aaron said, the most important thing is to ensure that you have overspeed. If you don't have overspeed, you're going to have that bubbling that was in his slide. That's a great illustration to show what can happen. So 3 to 5%. I've seen 20% because a customer wanted to play with ways to minimize adhesive buildup on their blades, and somehow, so there's different ranges there. I don't think there's any set answer because there's a lot of factors. There's blade diameters, there's condition of your equipment. There's a lot of factors involved, and but again, I think the most important answer to that question is you must have overspeed.
Got it. All a good reason to talk to the experts. Brian came in and was asking, what is the minimum diameter you can use on a top blade?
I can take that. So that depends on whether you're wrap shear slitting or tangent slitting. Okay, so if you're wrap shear slitting, there really is no chance for you to miss that wrap on. If you remember that little green section that was on there, that little green section for tangent slitting is where that blade has to hit. Now you have an offset for tangent for that reason. If you're wrap shear slitting, you might be straight up and down, and it doesn't really matter where that is. But because you're offset, you hit that little green section that you have to hit where the web is touching. At some point, that blade is going to be so small that it's going to be behind that little green section, that wrap where the web is touching. So if the blade is too small when you're tangent slitting, it's in the unsupported part of the web. And that's why, for example, Tidland's recommended minimum for a Tidland class 2, which is 5.906 new. It's roughly 5.4 for a minimum because of that chance that you're going to be slitting in the unsupported part of the web. The other factor is just simply, small trailer tire compared to large trailer tire. The small trailer tire is going to have a lot more revolutions. So your blade will wear much quicker if you have a much smaller blade compared to a newer blade. And so it's just a matter of preference if you wrap shear slitting and return on investment. So essentially there are numbers out there for depending on what blade you're running. And we can help you with that. Maxcess can help you with that. And a lot of it really is, it's not exact because you have to know exactly what your bottom band penetration into your web is to know exactly what your minimum needs to be.
Thanks, Tim. We got about
I'll add
5 more.
one other point I just want to add to that. Outside of the slitting setup, it's also safety related. So the smaller that diameter blade, we have a guard on the outside of the blade. And the smaller the diameter gets, now the gap between the edge of the blade and the guard starts to open up. And there's more of a gap where, say, a finger could get in when handling. So there's also that that safety aspect, and you'll see it published in our manuals. There's actually a value of, we don't recommend regrinding lower than a certain distance because of that. That maintaining that minimum safety gap between the guard and the edge of the blade as well.
Thanks, Aaron. Yeah, we said 5 more questions in the queue right now. So we're running a little over, which is fine. We'll let the experts answer the questions. Hopefully you guys can stay with us here for a couple more minutes. Benjamin was asking, I like the blade usage timers on the Control Series knife holders. However, the timers run when the knife is engaged, not the actual run time unless continuous run process. Our slitters constantly start and stop, which makes setting the timers tricky. Is there any plan to make the blade usage timers on actual runtime in the future? Aaron, I'll kick that over to you.
That's a great point. Yes, if it's a system, if we're making the complete system, and we can have done the drives, the motor drives, then we can do that. The issue with standalone knife holders is a lot of times the anvil drive of whether the knife holder is running or not is part of the machine and not our system. So we won't always have that input. And then we are, as a future improvements, we are looking at more, RPM counters that on the knife holder itself, where we can start to track that. So absolutely, we don't have it yet, but that's something that we're actively looking at.
Great, thanks, Aaron. Dominic asked, do you have a service center or partner in Canada, Montreal area, that can grind or slit?
So we have our local representatives, Nelco in Canada, in that area that provide coverage. From a Maxcess standpoint, for blade regrinding, we don't have any partners in that that are on that side of the border.
TJ, anything from the Valley side?
We certainly grind for a number of customers in Canada. So from Wisconsin to Canada, it's not too terrible, but we're familiar with getting everything through customs. And, you're looking at 2 to 3 days of in-house for us to grind it, and you'll get the knives back.
Great, thanks. Alex asks a question. Do you guys know or offer any kind of attachments that you can attach to the knife holders that help keep the top slitting knives clean and free of dust or adhesives while slitting?
Yeah, so we have a couple options. We have dust hood attachments that can fit on the knife holder with a provision for attaching a hose for suction, for example. So we have those suction hood attachments for dust. From an adhesive side, there are oil wick attachments that we offer that can build into the outside of the blade guard, where you can apply a felt wick directly to that top blade to again prevent adhesive buildup on the top blades as well. So those are the two best options. Question often comes up about coatings for shear slitting because of that overlap and that abrasion. Coating on blades it wears off too quickly to really provide any benefit. And we've done a lot of testing on that. So as of for better or worse, right now the best options are those oil wick attachments for adhesive.
Great, thanks, Aaron. Frank asked, for shear slitting, what is the recommended ratio of top blade to bottom blade in terms of OD?
So typically, there's the ratios are gonna, as long as the top blade is larger or it's smaller, that's generally what we do. I mean, there's different ratios that you can do for your setup of your machine that dictate your setback and other geometry. But as a typical setup, we might have a 90 millimeter top blade with a 105 or so millimeter bottom blade for some applications, and then depending on size. But the as a guiding principle, the top blade should be definitely equal or smaller. You wouldn't want to put a larger diameter top blade than the bottom.
Great, thanks,
And
Aaron.
if I can add to that,
Yeah.
Keith, sorry.
No worries.
But part of the reason, I mean, as TJ mentioned earlier, many folks do not change their female blades when they should. And so all they're doing is making more work for themselves by having to prematurely change their top blades. So, but the point is, most people don't change them because it's very difficult to change. And like if in a mill, it like takes an act of Congress to change, to get your bottom bands changed. I mean, there's just, sometimes it's very difficult. And so that's why on bottom blades, you see maybe a 3-degree bevel, and your top blade is kind of the sacrificial lamb in this equation, right? So you're changing the tops more often because they have a sharper angle and to allow for the cut. So part of that is simply the reason that bottom blades aren't changed is because it's difficult to change them. And so that's why they're larger, because they'll last longer. Okay. And your top slitter is typically a little smaller. So.
Thanks, Tim. Roman asks, for woven cloth, which is the better type of cut, razor, shear, or crush? And is there a specific setup?
Yeah, I think that would be a great opportunity if you have samples of the material where we could run some testing. I mean, generally shear, I would say, but in terms of the specific setup, we if we have the material in hand, we could really really do some a detailed evaluation to get the best recommendation.
Thanks, Aaron. Frank asks, what's the best method of producing a perf slit on a tissue web? Anybody?
Perf slit. So I'm that word I was perf. Okay, got it.
Perf. Yeah.
Okay, so yeah, I think the team at Valley Grinding has perforated blade options. For our crush knife holders, these can run perforated blades as well. It's a typical setup that we've done for many customers. So, for an anvil with a perf blade, that's one. On a crush setup is one. If you're looking for straight line perf versus other shapes and whatnot, yeah, you might need to get into more of a die setup if you want, repeating patterns and so forth. Tim, if you want to add anything to that.
Yeah, and so Tidland, they're class 1, 2, 3 knife holders. They have score cut cartridges, and they have score blades. They don't just shear slit. So depending on what you're trying to do, I'm sure if you reached out, they would be able to help you specifically to achieve what you're trying to get.
Great, thanks all. Danielle has a question. Can you briefly run over what type of work you do regarding Totani products? Saw it on your website. If applicable to us, I will pass on the proper party to reach out for additional correspondence beyond the call. So what work do we do regarding Totani products? It's saw it on the website.
From the Valley grinding side, we manufacture and sharpen the knives. So we do make new Totani knives. We actually make them for Totani, and we regrind them.
Great, thanks, TJ. Frank
on
has
the Maxcess side,
go ahead.
we on the Maxcess side, we supply equipment and systems, on an as needed basis.
Thanks, Aaron. Sorry for jumping on that. Frank said you indicated you can measure sharpness. How is this done and how is it reported?
Yep. So a couple different ways. It depends on the profile of the knife, but typically the best for us is through imaging. We have some equipment here that we can magnify up to 800 times, and you can actually see you can actually see how sharp your knife is. Some of the other ways in which we do it is we take the edge of the knife and we put it into almost like a dental impression, and you can see how sharp it is, and you can see there. We also use that for testing radiuses on knives, but the best way for us is we use image for it, and we can actually tell how high the peaks and valleys are for you, and essentially tell you how sharp the knife is.
Great, thanks, TJ. We've run a little bit over here, but we appreciate the questions and the enthusiasm. As I said, this is our first one. We're going to do it again. In order to give you guys some time back, what I think we're going to do is our frequently asked questions. We'll just put those in an email we'll send out to you so you get the answers to that as well. But again, thank you for the feedback. Thanks for joining us today. Our subject matter experts are always available. If you have any other questions, please reach out to us, and we'll help make sure you get your shear slitting and all your slitting applications optimized and performing great. As I did say, we do have this recorded, and anybody that's been on the call will send you a link to the recording, and look forward to doing some more educational seminars. Again, thank you for the enthusiasm and the participation. Thanks to our subject matter experts, Aaron, TJ, and Tim. Thanks to the marketing team behind the scenes of Amela, Eva, Jen, the people at Blue Door, all bringing this together. So thanks again. Have a great day, and look forward to giving you another one of these again. It looks like they're well worthwhile.
Thanks, everyone.